Okay. Well, next up in our quadrilaterals are trapezoids. Now, trapezoids are not parallelograms. They're kind of the cousin of a parallelogram. Um, but they are quadrilaterals. So, in a parallelogram, the primary um, property, kind of its definition, was that it's a four-sided figure, a quadrilateral, with both pairs of opposite sides parallel. And we stress the word both. In a trapezoid, we have a quadrilateral where only one pair of opposite sides are parallel. So that's a key difference. With that comes from some differences in the properties and some vocabulary that we have to be careful and aware of. So let's jump right into it. In trapezoids, we have only one pair, exactly one pair of parallel sides. Now, those parallel sides are called the bases. So we have some terminology. We've used all of this vocabulary before when we did triangles. Well, now we have a trapezoid. Think of a trapezoid kind of like a triangle where the point is cut off. So we have bases, we have legs, things like that. So the parallel sides are called the bases, and those are parallel, but they will never be congruent. In a trapezoid, we have two parallel sides that are called the bases, and they will never be congruent. The other two are called the legs. Now that's really important. Most of our work is going to be with isosceles trapezoids. So think in the think the vocabulary. Think of vocabulary used in isosceles triangles. We have congruent legs, a base. Well, now we're going to have congruent legs and two bases. We had base angles. We're going to have base angles here as well. So we're starting off with trapezoids, and then we'll make it isosceles. Trapezoids have base angles. Remember, base angles sit on the base. So I'm going to use a different color here. Two pairs of base angles. We have base angles that sit on one base, and then we have base angles that sit on the other base. So those are the two pairs. Now, we're not making any assumptions about their measurements at the moment. I'm just identifying them. One pair sits on base AB, the other pair sits on base DC. And we have parallel lines, so that means that we are going to have to deal with some angle pair relationships. So since we have parallel lines, we do have consecutive interior angles that are supplementary. So again, that's nothing new. We have to remember that it matters. So we have a little bit of vocabulary there. We also have something called a median or a midsegment. Now, in a triangle, they were two different things, a median and a midsegment. Here, they're actually the same thing. So in a trapezoid, the median and the midsegment really are the same thing. It is parallel to the bases, and its measurement is 1/2 the sum of the bases. So we can see a formula there. Top base plus bottom base, and then divide by 2. When we get to isosceles triangles, now we're going to add in the things that we already know about isosceles triangles. The legs are congruent. Base angles are congruent. Each pair of base angles are congruent. So the two angles that sit on AB are congruent. The two angles that sit on DC are congruent. And the diagonals are congruent. So we have a group of properties. Let's just jump right into examples. We're asked to find the missing angles. Notice in our picture that these are isosceles triangles. Most of our work is with isosceles triangles. In isosceles triangles, we have base angles that are congruent. So angle A is 53, angle B is 53. They sit on the same base. And then we have consecutive interior angles supplementary. So angle A plus angle D have to equal 180. So that's 53 plus x equals 180, and we get 127. Well, again, base angles are congruent, so 127. The legs serve as our transversals connecting the parallel lines. In number 4, it's the exact same picture, but rotated. So we're going to approach it the same way. Since AD is the base angles are congruent. Along the leg, we have consecutive interior angles that are supplementary. I'm sorry, not 103. I don't know what I was thinking there. 80, 70. I'm having issues today. 180. I got to think a little slower. I got to wake up. 83. Now my pen. Okay, there we go. 83. And of course, our other base angle. Whew, need that coffee to kick in. Let's look here. We'll just blow it up, work with one at a time. We're looking for the length of RT, so I'm just going to treat that as an X. RT is our median or our mid segment. So we know that the median equals 1/2 of the sum of the bases. So X equals 1/2 7 plus 13. So that's 1/2 of 20 or 10. So our segment here is 10. Think about the bottom base. The width of the trapezoid is 13. At the top, the width is only 7. We're going halfway between those two numbers. So we take their average. Number 7, it's the exact same thing. So x plus 1/2. X equals 1/2, 9 plus 12. That's 1/2 of 21. So we get 11.5. Looking at number 13, it actually is the same problem. Now we're looking for the other base, but the equation is the same. The median or mid segment is 1/2 the sum of the bases. So the formula is never going to change. Plug it in, then we'll work out our algebra. Remember, algebraically, you can distribute that 1/2, or you can multiply both sides by 2. So that's usually the way I like to do it. And now we're going to do 64 minus 43 for 21. We should always double check our answer and make sure it makes sense. We're going from 43 down to 32 down to 21. The numbers are getting smaller as we go. Of course, we could look at it from the other direction. We could also say from 43 to 32, it went down 11. So from 32 to 21, again, it went down 11. So we can make sure that our answers are reasonable. Same exact problems, just stepping up the algebra level a little bit. So the median or the mid segment, remember they're the same thing in a trapezoid, is 1/2 the sum of the bases. Again, you can multiply by 2 on both sides, or you can distribute to 1/2. Now, since these are even numbers, distributing to 1/2 works out nicely. You can do it either way. 4 equals 2x and x equals 2. plug in our answer to make sure it makes sense. And in our last example, again, or our next example, I should say, again, we're not doing anything different. The only thing that makes the problem a little more challenging is the level of algebra. Combining like terms. And again, our choice is multiply by 2 or distribute to 1/2. In this example, again, I prefer the multiplying by 2, simply avoiding the fraction or the decimal. We have 28 equals 7x and x equals 4. So a few examples. The exact same formula, just changing the algebra a little bit. And that brings us to our last two examples. Now, in these examples, we have to draw the picture. So far, when we draw the picture, we've really stressed the idea of choose one vertex and go right around it. It does not matter where you start, and it does not matter which direction you go. Well, that was true with parallelograms. That was true with triangles. With trapezoids, it matters. So we have to be a little bit more careful, and it might require a little bit of trial and error. So I'm going to try it, and we're going to see if it works. We have an isosceles trapezoid. So remember, in an isosceles trapezoid, and you can orient the picture whichever way you want. Most people are most comfortable when it looks like that. We have the parallel sides, and since it's isosceles, we have congruent legs. So we draw the picture. And I'm going to start in the top right and go around it. So I'm going to go clockwise. I'm sorry, top left and go clockwise. So P, I, G, S. Now that's what we've been taught all along. If we read the question carefully, and this is really, really important, isosceles trapezoid with legs P, I, and G, S. If we look at the picture that I just drew, PI is not a leg. PI is a base. GS is not a leg. GS is a base. So my picture is not correct. What I'm going to do is I'm going to shift the letters one position. Because otherwise, nothing's going to work. The picture has to be an accurate representation of that shape. So I'm going to redraw it, shifting the letters one position. So everything is going to start the same. But now I'm going to shift it one position. Or go in the opposite direction. That will work as well. So I can shift it P, I, G, S. Now I do have the legs P, I, and G, S. Or I can just go in the opposite directions. Well, let me just get that line there. P, and now go counter. I, G, S. And again, this picture works. So we have to be a little bit careful because bases and legs are different things now. So I have to be a little bit careful. So now that I have a picture that works, I'm going to put in those diagonals. They intersect at A. And let's see what they're told us. They gave us, let's see, different color. They gave us PA and GA, so I want to get them into the picture. PA is 2x. GA is 5x plus 2. And finally, the last piece of information that they're giving me here, and I'm going to find a different color. IS is 37. So IS is 37. Well, now that I have all the information, I'm just going to move over here where there's a little more room. And I'm going to remember a few things. Diagonals are congruent in an isosceles trapezoid. So that means the 2x plus the 5x plus 2, that makes up one diagonal, is equal to the other diagonal. And that's going to be the entire problem. That's everything that I need to know and everything I need to do. So 7x equals 35 and x equals 5. So we found x. So one, we have to get the picture correct. We have to be a little bit more careful than in the past between parallel bases and congruent legs. And for this question, we had to remember the diagonals are congruent. Now, in the second question, it's referring back to the same trapezoid, so I don't need to redraw it. I can, and I might choose to just to get a clean picture. So I could erase everything I wrote. I could redraw it to get a clean picture to start with. I don't know which is going to be the best approach until I try it. We have a median called ET. Well, let's think about a median. A median connects the midpoints on the two sides. So now we split those legs in half. Remember, the legs were congruent. Now we bisected both of them, so all four little pieces are congruent. E is the midpoint of PI. That means T is on the other side. So we need to read this slowly and draw one little piece at a time. We're told PE is 4. And we are asked to find GS. Well, again, a median or a midsegment connects the midpoints. So on PI, we split it 4 and 4. That is congruent to the other leg, 4 and 4. So x equals 8, or we could say GS equals 8. So remember that median or midsegment connects the midpoints of the opposite sides, or the midpoints of the legs. It is parallel to the bases, and it is equal to 1/2 the sum of the bases. And that wraps up trapezoids.